Assuming that you're coming to .NET, say, from Visual Basic 6, back in that environment, there was no need to worry about the details because you couldn't really even get involved in the process. You would select the event to handle and then write code to handle the event based on the name of the object and the name of the event. The name of your procedure, which combined those together, would be the only way to hook up your event handler to the event itself. Visual Basic Runtime would call the appropriate procedure based on the name at the appropriate time. But there's nothing you could do in Visual Basic 6 to alter that sequence of things happening. In .NET, it's a lot more complex and simpler at the same time. There's no need to worry about naming conventions because you control which procedure gets called in reaction to which events. It's more control than VB6 ever had or provided to you, but it also gives you more responsibility as well. In normal applications, you call your procedures. You create the parameters, you create the return value, but in an event-driven environment, your application has to react to events when these interesting things happen. User clicks a button, a timer tick, user moves a mouse. All of those are interesting things. As I mentioned earlier, the alternative would be to poll the keyboard at regular intervals, but that's really not something you want to do. That was the concept of Windows programming in the 80s. Instead, .NET will notify you when something interesting happens, and it will call procedures in your code in reaction to events. Let's look at a demo that demonstrates this behavior. I've opened the sample project for this section named Events, and I've opened the sample form I'd like to work on named Demo Form. And here you can see a button and a list box already created on the form. Let's start with the simplest example possible, and that is, again, add code to the click event of the button. To do that, I can just double-click the button, and it will take me to the default event for that button, or I could choose the Events tab on the Properties window and select the control, and then find the event I wanted to react to and double-click. Well, I've already done this here. Here's my button1_click event handler, and I can add code here. I'll add simple code, which simply broadcasts Hello World. Apparently, every presenter is legally obligated to do at least one Hello World example for every course. In any case, how does this get hooked up? Well, we'll see later how that works, but some magic somewhere indicates to the .NET runtime that if I click on that control, I should run this procedure, or it will call this procedure, passing in sender, which is a reference to the object that raised the event, our button, and event args E, where E has information about the event itself. If I look at properties of E, there's really nothing there that's interesting. So in this case, there is no useful information passed to us in E, although in some cases, in the next example, for example, there will be. Well, let's save this and run it. I'm pressing F5 to run. And most likely, as you expect, if I click the button, magic happens. The .NET runtime recognizes that I have clicked the button, and it calls the click event handler for that button. How about that list box? Well, the point of it was so that I could register everywhere I've clicked on this form. What I want to do is handle for the form the click event. And in the click event of the form, well, that's interesting. If I just handle the click event, the event args passed to me aren't very interesting. I think that's the wrong event, and you can see which event I actually do want. Let me delete this event handler, and that's going to cause its own set of trouble, but we'll see why in just a moment. Let's go back to our designer, and instead of the click event of the form, I want to handle the mouse click event. I've already added this event handler. I can just double-click again, and it will take me right to the existing event handler. This time, this event gets handed a mouse event args object. A mouse event args object gets lots of interesting information. Button, clicks, delta, location, X, and Y are all properties that the normal event args object don't get. This gives this procedure information about which button was clicked, where it was clicked, and so on. So I can put that away, come to my code that I've already written, and see that when we click the mouse click event occurs. This occurs actually when the mouse goes down. When it comes back up, there's another event handler that occurs. Here I want to take e.x and e.y, create a formatted string using the string.format method. String.format, if you haven't seen it before, allows you to create a template that defines how you want the output string to look. In this case, the 0 placeholder is replaced with this parameter, and the 1 placeholder is replaced with this parameter at runtime. We'll take that location text and insert it in the 0th position of the items collection of the list box every time we click the mouse. Now remember, I created an event handler for the click event of my form. If I attempt to run my project right now, it's going to fail. Let me show you why. It says events does not contain definition for demo form underscore click. Well, I deleted it. Why is it complaining? Well, we'll talk more about this in a bit. But when you add an event handler, the designer creates a line of code for you to hook up that event handler. And because we deleted the procedure but didn't delete the line of code that hooks it up, we get an error. Let me just delete this line of code. I'm showing you this here because this will happen to you. There's no chance that sooner or later you won't do what I just did, which is create an event handler, delete the event handler, and then need to fix it up when you attempt to run the project. We'll discuss later how the event handling gets hooked up, but for now, if you get yourself in that position, just delete the bad line of code. Let's run this project. And now if I click on any place on this form, you'll see the location gets added to that list box at the topmost position. Each time I click, it pushes that down an item. So you can always tell where you are in the form. If I click up here in the left-hand corner, for example, if I'm lucky, I can get 0, 0. Didn't quite have the manual dexterity to get 0, 0, but I did get 1, 0. So you can see that you're tracking the location on that form in the mouse click event of the form. You might want to use a form as a dialog box. What if you want to display a form and retain the focus while that form is visible? You may need to retrieve information about the user choices while the form was visible. You might want to be able to press Enter or Escape and act as if the OK or Cancel button was pressed. That's the standard behavior on a dialog box. Pressing Enter acts as if OK was pressed. Pressing Escape acts as if you'd clicked Cancel. And the .NET runtime makes this all easy. By default, controls on forms are private. You can change the modifier's property to make them and their properties available outside the form. But it's better to create a user-defined property that exposes the value that you need. The property might look like this. A username property, for example, that returns a string. The property getter returns the value of a text box's text property, and the property setter sets the value of the text box's text property. This way, no one outside the form can see the actual text box. That's a private matter to the form. But anyone outside the form could see the username property. This way you could change the name of the text box, and only the code inside the form would need to be changed. All the code outside the form would still access the value by using the username property. Continuing the issues involved with creating a dialog box form, the dialog box form often will react to the Enter and Escape keystrokes, as I mentioned. Each key triggers the click event of one of the buttons on the dialog box and acts as if you had clicked the button, and runs the click event handling code associated with the button. To make this happen, you set the form's Accept button property to the OK button that's on your form. It'll actually let you select the actual button. Pressing Enter then clicks this button, or acts as if you had clicked it. Set the form's Cancel button property to the button you want as your cancel button, and then pressing escape acts as if you had clicked that button. So you need to set two properties of the form, accept button and cancel button, to refer to specific buttons on the form. But there's more to it than that. We need to be able to retrieve the return value. That is, whoever loaded this form wants to know, did the user click OK or cancel? Well, you need to tell the button, each button, the OK button and the cancel button, what they should return if they're clicked. Each button can return a value through the form's showDialog method. Up to now, we've only looked at the show method, which loaded the form in a non-modal way. The showDialog method of the form loads it modally so that it retains the focus until you close it or hide it. So, the showDialog method will return whatever value of the button you clicked. So you could set the OK button's dialog result property to the actual value OK. There's an enumerated value which represents all the possible return values. OK is one of them. You set the cancel button's dialog result property to cancel, indicating that you've canceled the form. If the dialog result property for a button is set, clicking the button closes the form. Actually, it hides the form. It closes it off the screen, but the contents of the form's code and properties are still available because it's just hidden, not actually removed from memory. The code that opened the form can check the return value of the form's showDialog method to see which button the user clicked, OK or cancel. It can also retrieve a property of that form, like that username property we set up previously, to determine what the value was for that property. Well, we're not quite done, because we also need some way to start the application and indicate which form is the startup form. That is, how do you specify the first form to be loaded? Well, in code, every application has a procedure named main. The .NET runtime looks for this procedure and calls it. Main never has a return value, but could optionally have input parameters. Within main, you need to call the application.run method and pass application.run an instance of the form class for startup. The code looks like this. The main procedure must be public and static, meaning that there's no need to create an instance of the class that contains it before calling the procedure. In addition, it must be void. It can't return a value back. It can either accept parameters or not. In this case, it doesn't. You call application.run, you pass an instance of the form class you'd like to be displayed when the application starts up. In this case, that's switchboard. Application.run gets it loaded up, sets up looping and message queuing and all this stuff so that the application can communicate with it, and keeps it in memory until you close it. Application.run takes care of all these things for you, so it's not enough to just create an instance of the form and show it as the main application window for your application. The main procedure must be accessible. That means it can't be private. And it must not require an instance of the class, as you saw in the code sample. Generally, you won't need to create your own main procedure. Visual Studio will create it for you. If you need to run special code at startup, you could add your own or modify the existing one. But in general, for most of our demonstrations, we'll never need to look at it again. You can use the project properties to change the startup object, and it will recreate that main procedure for you, calling application.run with the correct form. Let's look at a demonstration of working with dialog boxes and the startup form. I've run the sample project once again. I'll click Dialog Form, and now once the dialog form is open, I attempt to click on Switchboard Form, and I can't, because the dialog form has grabbed the focus and won't let it go until I either click OK or Cancel, or press Enter or Escape. If I enter a name here, and then click OK, my application knows that I entered Ken. Let's try it again. This time I'll just press Escape, and we'll know that we were canceled. So the information must be available to the main switchboard form. Let's start by looking at the switchboard form. look at the code for this. Here's the code we'll use to display that dialog form. Now notice that I have a using block around the whole thing. The using block is a construct in C# which causes an object to be available until the end of the block, at which point, at the end of the block, it is destroyed. It's disposed. It's removed from memory. If we hadn't done that, remember that when you click OK or cancel, this form isn't removed from memory. It's just hidden so we can retrieve its values or find out how it was closed. So in this case, we need to make sure it gets removed from memory. And when you create a dialog form, you generally use the using block to ensure that once you're done with it, it gets destroyed. Here we're saying using dialog form FRM equals new dialog form. We'll create the instance. And here we'll call frm.showDialog. That opens the form in a modal fashion so that it grabs the focus and keeps it. We use a switch statement based on the return value from this method, and we'll never get past this method call until we either press OK or cancel, or press escape or return. If we press return or click OK, we'll end up here, and we'll display the username property of that form. If we click cancel or press escape, we'll end up here instead and display the word canceled. Well, that's easy enough to understand. The question is, how do we set up the OK and cancel return values? How do we set up the username property of the form? To do that, let's investigate the dialog form. Here's the form, and remember we have the OK and cancel buttons here. For OK, I've set the dialog result to OK, so that the calling code, that showDialog method, knows that if I click this and this returns OK, that it should return OK back to the calling code. The cancel button has its dialog result set to cancel. The form has its accept button property set to button 1, that's this, and its cancel button property, lost it, there it is, set to button 2, that's this one. So the form knows that this is its cancel button and this is its OK button. That takes care of all of the plumbing involved. Now how about that username property? If I look at the form's code, I can choose View Code to get there. You'll see in here that we have a username property, as you've seen already. It's a public property named username, and it returns or sets the value of textbox1.text. If I look at the design once again, we see this text box's modifier property is set to private, which means this text box cannot be seen from anywhere outside of this form, and that's the way it should be. Yes, you could fake it by setting this to be internal so that anyone else, any other code in this assembly could see that text box. But really, you don't want to do that. Expose the username as a property of the form so it encapsulates the behavior of the form. I don't care how we got the username from outside the form. It could have come from somewhere else. But in our case, it's coming from the text in that text box. Let's review how the startup form for this project got set. If I go to the project properties, I can get there by just right-clicking on the project and choosing properties. You can select the startup object here, and you can see that I've chosen events.switchboard. That is the switchboard form within the project named events. That way, the code is automatically generated to call application.run using the switchboard form. Remember, at the appropriate time, the .NET Runtime calls your event procedures. Therefore, they need to meet certain requirements. The code and the .NET Runtime have to agree on the parameters and the return values for your event handlers. If they don't, the .NET Runtime can't call your event handler. .NET provides a special data type that defines the layout of a procedure, that is, the parameters and the return type. This data type defines the event handler type for each instance of your event handler. For example, the click event handler has to have two parameters. The first one has to be an object. The second one has to be an event args instance. This way, your code matches what the .NET Runtime expects your code to be, so it can just call your procedure as needed. This type is called a delegate. The system.delegate type defines the behavior of procedures. An instance of a delegate specifies an exact set of parameters and a return value. A procedure can be of a particular delegate type if it matches that delegate's requirements. Event handlers must match the event's predefined delegate type so that the .NET Runtime can call the event handler. If there's not a match, your code simply won't compile. The event declaration for the click event looks like this. It's a public event. The type of the event, the delegate that defines the event, is event handler, and the name is click. The definition for that event handler looks like this. It's a public delegate. Delegate means this is a type that defines the behavior of a procedure. It's a void procedure. The name of the type is event handler. It must accept two parameters, the first one of type object, the second of type event args. So if you want to have a procedure handle the click event, it has to have this general shape. Same thing goes, say, for the mouse click event. The event declaration looks like this. It's a public event, mouse event handler is the type, and mouse click is the name of the event. And the mouse event handler looks like this. It's a mouse event handler, it's a delegate. It accepts object as its first parameter and mouse event args as its second parameter. If you want a procedure to handle the mouse click event, it must have this particular shape. Let's review how this code hookup works. If I find my form I'd like to investigate and open its code, I'll right-click and choose View Code. You'll see we have our public partial class named Demo Form. And if I expand that node and look at the Designer class, you'll see here again a partial class Demo Form. The two are merged together at compile time into a single class. Down here, we have our declaration for the button control. And when our form loads up, there's code that first creates the instance of that button and then later adds the control to the set of controls on the form. What this doesn't explain is how does the click event get hooked up? Well, I'll show you here first. We'll go back to slides and discuss it. If we find the button set of control properties, we'll see here this.button1.click plus equals new system.eventhandler and the procedure we'd like to have that click event call. This line of code hooks up the event handler. Click is a property of the button. It contains a linked list of event handlers, meaning you can have more than one event handler for the click event. We'll look at that later on. In any case, right now we're hooking up one instance of the event handler delegate, and this, which we pass to the constructor of that event handler type, is the button1_click procedure, which will get called when you actually click the button. This one line of code provides the hookup between the .NET Runtime and that procedure, so it gets called at the appropriate time in the lifespan of this form. Now, if you want to type this yourself, Visual Studio gives you some help. If I type this.button1.click and then press plus equals, you see the tooltip that shows up. It says, here's what I'm going to insert if you press tab to insert it. If you don't, you can always type it yourself. I'll press tab once, and now we get the new system.eventhandler set up for us. And if there wasn't already a button1_click, I could press tab again to create it for me. Since it already exists, that's what the tooltip says, that it already exists. In any case, you can add a different event handler. Let's try a different one. This.button1.say double click. Then plus equals. I press tab. You'll see you get a tip which says you can press tab again to generate the handler for the double-click event handler. When I press Tab again, it gives me the event handler with an exception, that is a throw statement, which will throw an exception, which will raise an exception as part of the runtime because I haven't yet added code for this event handler. Now you've seen a number of different ways to create event handlers. You can do it here, as you've seen, or you can always go back to the designer and just double-click the appropriate event and have them generate the procedure for you. Now, if I delete this procedure, I must go up to my code where I set it up and remove the hookup here as well. In addition, unless I want to run my click event handler twice when I click the button, I need to also delete this extraneous hookup for the click event handler. This code explicitly defines what will happen when any event occurs. So if you have two calls to the click event handler, you're going to get the code run twice at runtime. So far, you've seen one event handled by a single procedure. You can also have one event handled by multiple procedures to have multiple things happen when the event occurs, or have multiple events handled by a single procedure, so that you could have one procedure that would handle multiple different events. Maybe you want to have click events of multiple buttons go through a single procedure. We can set both of these up within Visual Studio. If I click multiple controls here, you'll see that I have 3 buttons on the form. If I click each of these buttons, it tells me which button I clicked. Button 1, button 2, button 3, and so on. Now, let me click the button named Multi-Handler. Let's click the checkbox down here, and here, type some text. So you can see that I can have, well, you'll see in the code a moment later what multi-handler does for us. Now that you've seen the demonstration, let's go into the code and see what this all proved. This was multiple controls. There is the form at design time. Let's look at the code. View, code. And you can see in here, we have a procedure named button handler. And button handler takes whatever you've passed to it in the sender argument and casts it as a control. Not quite sure what kind of control, it's just a control, but it certainly isn't an object. We know that it's some kind of control. We'll create a string builder, and a string builder is an object which allows us to append text to a buffer and then display that text later on. So we'll append a line, button handler, which is the name of this procedure, and then append to that a formatted text which is handling a click event from whatever the name of the object that got us here was. So button handler must be used from multiple different buttons. Let's see about that. Let me find multiple controls here. Go to its designer, go to the various buttons, and see how they're hooked up. Looks like button 1 _ click uses button handler. Button 2 uses the same procedure. Button 3 uses the same procedure. Anybody else? Nope. It looks like the others use a procedure called multi-handler. We'll look at multi-handler in a minute. So button handler looks like it's a procedure that you might use to handle multiple button clicks. So all of the button clicks are going through here. Multi-handler does something a little bit different. Multi-handler not only uses the sender cast as a control and stored in this variable, still builds a string builder, and still displays some text. But in this case, it determines not only the name of the control, but the type of the control. Using the getType method of the control, we can get the name of the type and see that we were a button, or a checkbox, or a text box. This event handler will handle all the events for all those controls. Let's try it again. So here you'll see we're calling the same button handler procedure. Down here we're calling multi-handler for each of these items. And you can see that this text tells us what kind of item we're working with. Now let's try one more experiment. Just for grins, let's come to our code, say here actually, and let's say for our button, I'd like to hook up the mouse move event to use that multi-handler. Maybe the text box. Let's try it. This.textbox1.mouse move, say, plus equals, and let me put in here not textbox1.mouse move, but instead multi-handler. What's going to happen when I compile this? Let's build the project. It didn't seem to care for the mouse move event. That seems odd. Multi-handler, let's go look. Multi-handler took in an event args. The funny thing is, in Visual Studio 2008, they have relaxed the requirements on these event delegates. It's important to note this. In prior versions, this event delegate had to match exactly. In the current version, as long as each of the parameters is either of the correct type or of a base type for the correct type, it'll work just fine. You won't be able to get the information you need, however, for the mouse move event, which is where is the mouse, because event args doesn't give us that information. In prior versions of Visual Studio, this would not have compiled. In this version, it will compile and it will work, but we won't be able to get mouse information out of an event args object. We'd have to create an event handler which does accept a mouse event args to find out where the mouse was when the event occurred. This is a nice new addition in this version of Visual Studio that allows you to have relaxed event delegates. Although Visual Studio creates event handler hookups for you, if you want to handle an event with more than one handler, you'll have to add the hookup yourself. And the code might look something like this. Here we'll have 3 handlers for button 1's click event. In each case, we use the plus equals operator to add an event handler to the linked list of event handlers and specify the address of the procedure you'd like to call. In this case, handler 2 will get called, then handler 1, and then handler 3 for each click of the button. If you want to remove event handlers, use the minus equals operator. Otherwise, the syntax is exactly the same. Let's look at an example which demonstrates using multiple handlers for a single event. In the sample project this time, I'll click multiple handlers. Here, this button currently has no handlers. Click it, does nothing. I click the Add Handlers button, and now it does have 3 handlers, and there they are, and they run specifically in the order 2, then 1, then 3. Let me clear the display, remove the handlers, click it again, and again we have no event handlers. Let's see how that's happening. I'll go down to the multiple handlers form, and first of all, notice that there was no click event handler. I'll delete this, but remember, if you delete that, when you next try to run it, let's just build it, we'll need to fix this error by removing the extraneous click event handler there. Okay, now that I've fixed things up back on our form, let's look and see what this button does. This button hooks up 3 event handlers for that button click event. The order that we specify them here is the order in which they get added. We'll add an event handler for handler 2, for handler 1, handler 3, and those event handlers simply display into the list box on the form which handler they are. When I click the bottom button on the form, I'm removing each event handler in turn. Doesn't really matter which order I remove them in, but we need to remove them all. Just for fun, let's not remove one of them and see if it still operates correctly. Let's save it, run it again. This time, of course, we have no event handlers right now. We'll hook them up, and I added handlers twice. And you notice that, of course, since I added the event handlers twice, each one is run twice. Well, that's not what I intended to show. Let's add handlers, prove that it works, clear the display, remove the handlers, and now click the button. Handler 2 still remains. Because I commented out the line of code that removed that handler, it still gets run in reaction to clicking that button. So you see, you have full control over how and when the event handlers run in reaction to some event of any object on your form.